Hello everyone, welcome to my e-learning session of single phase induction motor, which is the topic of basic electrical engineering. Introduction to single phase induction motor. As we know that an electrical motor is an electromechanical device which converts the electrical energy into mechanical energy. The single-phase induction motors are simple motors which operates on single-phase AC supply and in which torque is produced due to introduction of electricity and which is caused by the alternating magnetic fields. The single-phase induction motors are more economy rather than three-phase induction motor. That's why a single-phase induction motor are used in most houses, offices and also in rural areas. Types of single phase induction motor. The single phase induction motor may be classified into following categories. First is split phase motors, second is shaded pole induction motor, third is reluctance start induction motor, and fourth is repulsion start induction motor. The split phase motors are again subdivided into four categories. First is resistance start motor, second is capacitor start motor, third is permanent split or single value capacitor motor, and fourth is two value capacitor motor. First is resistance start motor. The rotating magnetic field of resistance start motor is produced by the out of phase currents in the run and start winding. Since the run winding appears more inductive and less resistive than the start winding, the current flows in the run winding will be close to 90° out of phase with the applied voltage. The phase angle difference between the current in the run winding and current in start winding of the resistant start induction motor is generally 35° to 40°. Second is capacitor start motor. The construction of this type of motor is similar to the resistance split phase motor. The difference is that in series with the auxiliary winding, the capacitor is connected. The capacitive circuit draws a leading current. This feature used in this type of motor to increase the split phase angle alpha between two currents, that is between maximum current and the starting current. Now third is permanent split induction motor. The permanent split capacitor motor also has a cage rotor and the two windings named as main winding and auxiliary winding similar to that the capacitor start motor. It has only one capacitor connected in series with start winding. The fourth is two value capacitor motor. The two value capacitor motor is very quiet motor with high starting torque. It combines the characteristics of capacitor start motor and capacitor run motor. Now, the next type of single phase induction motor is shaded pole induction motor. This type of motor consists of a squirrel cage rotor and stator consists of silent poles, that is projected poles. The poles are shaded, that is each pole carries a copper band on one of its unequally divided part called shading band. Now next is reluctance start induction motor. It starts as an induction motor but run with small amount of synchronous torque. The synchronous torque is due to change in reluctance of the magnetic path from the starter through the rotor as the slots align. This motor is an inexpensive means of developing a moderate synchronous torque. Now last one is repulsion start motor. The repulsion start is a type of single phase induction motor with rotor having armature windings, commutator with a set of short circuited brushes and short copper disc with a clutch. Next is construction of single phase induction motor. Single phase induction motors generally have a construction similar to that of a three phase induction motor. These are the different parts of single phase induction motor where we have housing and starter. Feeds are provided to starter for the mechanical support An electrical connection is also provided on the top of stator. Inside the stator, rotor is placed and then shaft, and all these parts are connected with the end rings. Now this is the cross-section view of single-phase induction motor, where we have two types of winding. Red one is main winding and purple one is starting winding. Now the main parts of single-phase induction motor are stator, rotor and windings. The stator is fixed part of the motor to which AC is supplied. The stator contains two type of winding as we shown in figure, the main winding and auxiliary winding or the starting winding, and the both windings are placed perpendicular to each other. A capacitor is also connected in parallel with the auxiliary winding. The stator has laminated construction which is made up of stampings. The stampings are loaded on its periphery to carry the winding called stator winding or main winding. The laminated construction keep iron losses to minimum. The stampings are made up of material from silicon steel which minimizes the hysteresis losses. The stator winding or main winding is wound for a certain defined number of poles, means when excited by single phase supply, stator produce the magnetic field which create the effect of the certain defined number of poles. The rotor is the rotating part of motor. Here the rotor is similar to that of squirrel cage rotor which we had been discussed earlier. The bars are permanently shorted at both the ends with the help of conducting rings which is called the end rings. Working of single phase induction motor. For the motoring action, there must exist two fluxes which interact with each other to produce the torque. As we supply single phase AC supply in DC motor, field winding produce the main flux while DC supply given to armature is responsible to produce the armature flux. The main flux and armature flux interact to produce the torque. In the single phase induction motor, single AC supply is given to the starter winding. The starter winding carries an alternating current which produces the flux which is also alternating in nature. This flux is called the main flux. This flux link with the rotor conductor, and due to transformer action, EMF get induced in the rotor. The induced EMF drives current through the rotor as rotor circuit is closed circuit. This rotor current produced another flux which is called the rotor flux and required for the motoring action. Thus, second flux is produced according to the induction principle due to induced EMF, hence the motor is called the induction motor. As against this is DC motor, a separate supply is required for the armature to produce the armature flux. This is the important difference between a DC motor and an induction motor. These two fluxes produces the desired torque which is required by the motor to rotate. Now, why single phase induction motor is not self-starting? As we know that when Faraday's electromagnetic induction law is applied to the rotor, electricity is induced and force is generated on the rotor bars. But according to double revolving field theory, there are two magnetic fields with the same magnitude but revolving in the opposite direction. So, two forces vectors are produced with equal magnitude but opposite in the direction. Thus, these force vectors, as they are of same magnitude but opposite in direction, does not cause the rotor to rotate. So, single phase induction motors are not self-starting motors. The motor simply buzzes in the condition. To prevent this situation, the rotate the rotor. The starting force has to be applied for a single phase motor, as the force in one direction becomes greater than the force to other direction. The rotor start rotating. In single phase induction motors, auxiliary windings are used for this purpose. Thank you everyone for watching my video.